Hey everyone, welcome back to Dan91's garage. In this episode, I'll be fitting a replacement actuator to the TD04 turbo that I ported out last week. Managed to get this unit off of eBay. It was only 15 quid. I think that's an absolute bargain. So while we're at it, we might as well chop open the old actuator because it's completely knackered. That way we can see what's inside. I'll talk about what an internal wastegate is, how to set one up, and how you can get a few extra PSI out of what is basically a standard turbo. So it's over there on the bench. Let's crack on, and I'll see you in a sec. So we'll start with the basics. I've reassembled the turbo, so the turbine housing is now back on. It's quite simple to do. There was no need to show on camera because you saw me took it apart, and obviously you just have to reverse the process. So this is connected to the exhaust manifold, and the exhaust gases come rushing out of that, straight down this, and then they go into this scroll. There's a sort of cylindrical opening inside there, allows the gases to pass through the turbine wheel, and then they come out this way through to the exhaust, spinning the turbine, which is obviously attached to a shaft that spins the compressor wheel, which draws air in through here and expels it under pressure out through the compressor exit. Obviously it will get to a point where it needs to regulate itself because you only need a certain amount of boost pressure going into your engine, and that's usually done with an internal wastegate which needs an actuator attached to the turbo. So what happens is the gases obviously go in here now, but there is a second pathway that is covered up by this trapdoor, obviously known as the penny sometimes. I call it the wastegate, some people call it a penny. So what we can do to reduce the amount of gas flowing through the scroll and reduce the amount of energy being transferred to the turbine, we can then divert them out of the wastegate path, which will then bypass the turbine wheel, and instead of spinning it up, they simply go round the side of it, as it were. And this is controlled by an actuator. So the path itself is basically 90 degrees to the entry to the scroll, and this is where the gases come through the side, essentially, of the inlet wall. So we'll attach the new actuator, 2 bolts and a 13mm spanner. So the actuator's role is to open or actuate the wastegate at the desired boost pressure, and this is set by spring force. A boost reference hose is connected from the compressor housing and feeds boost pressure to a chamber in the actuator, which is sealed with a diaphragm. This diaphragm moves a piston, which pushes against the spring force. The piston has a rod attached to it. The other end of the rod obviously connects to the wastegate lever. So as the rod is pressed out, it opens the wastegate, allowing the exhaust gases to bypass the turbine wheel, slowing the shaft down, creating less boost. Now this sounds like an ideal opportunity to cut the old actuator open and see what's going on inside. We got it. Now this may well, yeah, this is going to explode. Ooh, no. And there it is. Class. Well, there we are. So there's a rubber diaphragm inside it. That's obviously, it's like it's crimped on in between these two pieces. Sort of crimped between the top half of the shell and the second part of the shell. And you obviously got, there it goes, piston inside. So that's the piston with your big ass spring against it. Bit of a washer to stop your crap and dust getting in. That's nice. Turnbuckle thing on the back. There's the diaphragm on there, and that pushes up against the piston, so something like that. So that was cool. The spring is sealed in this example, but the length of the rod can be adjusted. You can see on this example it's set from the factory with some green paint. When a boost controller is not installed and the spring is sealed in the actuator, we can adjust the length of this actuator rod to increase or decrease the boost pressure produced by the turbo. If we shorten the length of the rod, it will increase the preload on the wastegate spring, which in turn increases the pressure level required to move the piston to open the wastegate, and therefore the boost pressure the turbo can generate will increase. If we lengthen the actuator rod, the opposite will happen. The HKS actuator for the stock CT9 turbos are adjusted in this way and has a good amount of travel. The length settings and approximate boost are as follows. Pause the video at this point if you need to check them out. The stock CT9 actuator has two ports. On the standard setup, one is connected to the compressor housing for boost reference and the other to a boost solenoid. In low boost mode, the solenoid is kept closed and therefore the wastegate actuator sees the full boost pressure being produced. Then, in high boost mode, the solenoid opens to bleed off some of the boost reference signal, which means less pressure in the actuator, in turn reducing the wastegate opening, which increases boost. When running a CT9 turbo with a bypassed or removed boost solenoid, the first actuator port is still connected to the compressor housing for boost reference, but the second port is left open to atmosphere for high boost, or can be blocked off with a hose and bolt to run in low boost. From memory, the two actuator ports have different size restrictors in them, so must be plumbed to the correct configuration. So small adjustments only, let's say half a turn at a time. Monitored with a boost gauge or serious engine damage can occur. Increasing preload too much can lead to undesirable boost spikes. It will also decrease the actuator's travel, and in excess, this can lead to boost creep as the wastegate won't be able to open far enough to divert the exhaust gases to slow the turbine. None of this is a replacement for a manual or electronic boost controller, it's just a minor tweak to get a few extra PSI or return a slightly tired actuator to its default setting. This is a dogleg rod, and I've had to pull it over and it's no longer coming out of the back of the actuator at the desired angle. It's sort of been pulled over to one side and it's actually very tight to the exit hole here. So what I'm going to do is just loosen this off slightly, twist the rod around until I get it to the position I want, then nip it back up again. I'm not going to put any extra turns on it because I don't really need any extra pressure for this. So if I pop this off, and that's its natural position with the rod coming straight out of the actuator housing. So what I'm going to do, gently loosen off the lock nut. Which is locked to the shaft. Well, hopefully, as you can see, there's some red thread lock on that locking nut from the factory, so that's obviously set on there, so you can't move it up to shorten the rod. So what I'm going to do is heat that up with the lighter to burn off the thread lock. That way I can actually lock it back onto the attachment at the end. All I want to do is manipulate this rod so it comes out of here at the correct angle when it's fitted to the turbo. I may have to adjust this as well depending on how I clock the turbo, depending on which way round the manifold is. So if it's a top mount, I'm going to have to move the compressor housing, and if it's a bottom mount, I'm going to have to sort of manipulate everything on the turbo to get it into the correct orientation. So this is going to have to go on a separate additional bracket probably, but to do that I am going to need to be able to adjust this nut. So obviously, as with everything, when you're adjusting stuff that increases turbo pressure, steady as you go, because a little adjustment here could make a big difference to how well your rods are connected to the pistons. So take it easy. I'm just going to free this off and we'll go from there. So the old favourite, lighter and a 10mm spanner, heated up the nut, which seemed to free off the majority of the thread lock they'd put on. I think it's supposed to be permanent stuff, and thankfully they've pressed a flat into the actuator rod, which I've been able to grab in the vise here, And then once I'd heated it up, just to loosen the thread lock's grip on the nut, she now moves about free and easy. So now I can move the nut and lock it back up at the desired angle. So I was trying to clean up this nut to get any of the residual thread lock out of the threads, but I couldn't get the tap in it, so I thought the threads in it were a bit knackered, but it turns out they've used a fine pitch thread as well. So it's M6 by 0.75 as opposed to M6 by 1. So that'll obviously allow for smaller adjustments for more accurate setting of the actuator. It's actually quite a cool little thing, that. So that's now coming straight out the back of the actuator. This is now flattish. It's actually a slightly different angle to the lever here, so I may have to manipulate this rod a little bit later on. We're going to have to nip that back up. So I've just popped the rod off of the wastegate lever, and you can see it's pretty much the entire diameter of the shaft that's on the lever there. So we need to stretch that over. That pops onto there, and that puts some tension onto the spring. Now you need to snap the circlip back on, and she's ready to go. So that's it. Hope you liked the video. Thanks for watching. My name's Dan. This is Dan91's Garage. Don't forget to like and subscribe, and I'll see you on the next episode.